Hello, class, and welcome. Today we'll be going through uh, statistics, elementary statistics of organizing data. We'll be looking at how when you collect raw data, how you can organize it into uh, some tables and graphs so that you can be able to make sense out of the data. We will be looking at specifically starting with frequency, uh, distribution of data. So what is frequency distribution? A frequency distribution basically mean taking raw data and putting it into a table wherein each data point is grouped or classified or put into a class so that it can be able to be organized or understand, summarized, and interpreted. Take, for instance, we collect information on the student gender. So a student could be a male or a female. So if we sample maybe 6 students, maybe female, female, male, female, maybe male, 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 and male. Actually, this is a student. How do we look at this data and make sense out of it or interpret it easily? Is for one way is for us to start by organizing this data into a table wherein we will group all of those that are female into a single class and all the male into a single class. And then each of those groups, we call them, they will be called groups, and then, or you can call it as a class, and then each of those values will be counted for each of the class and then form a frequency. So for instance, this one, we have a class of females and a class of male. What is the frequency? Simply meaning how many of those persons we sample are female. If we count here, we get 1, 2, 3 as female. So we write that as the frequency for female. And then we'll go for the male. How many of them are male? 1, 2, 3, 4, 5. So 5 male. So this counts against their group is what we call frequency distribution. Here, if you sum the frequencies, you should be able to get the sample size that you deal with. So if we add 5 plus 3, that will give us 8. So our n is actually equals to 8, which is the sample size. There are other things we can do with this data to make more sense out of it. We can calculate what we call the relative frequencies. Relative frequencies. That is, we are going to look at each category, the proportion of the presence in that category in regard or with relation to the whole sample that we collected. So the relative frequency here for female will be 3 divided by 8. And then the relative frequency for male will be 5 divided by 8. This will actually give us, I think we need a calculator. In all statistic classes, always try to have a calculator with you because they will be useful. So if we divide 3 divided by 8, we are going to get 0.4. And if we divide 5 by 8, we are going to get 0.6. So these are relative frequencies of this particular data. Actually, relative frequencies will always sum up to 1 if they are, we take them as proportion. Another thing we can calculate is the percent frequencies. That is what percent of those sample that we collected are in a particular group. Like for female, how many percent or what percent of the sample we deal are female. So normally you can just multiply the relative frequency by 100. So this for percent frequencies will give us 40% here. That is 0.4 times 100, 40%. And this will give us 60% for the male. The total should always sum to 100%. So you can see now we have a lot of information here on this data that we can interpret. If we look at it from where we came from initially, without organizing, we can't really get much information to interpret this data. But once we organize it into frequency distribution table, we can make a lot of sense out of it. One is now we know that over 60% of the sample we have gather, we are male. So you see that majority of the sample is made up of male, and female we are 40%. We can do that interpretation. Another thing we can do with this organized data is that we can organize this data into a graph. One major graph used for summarizing categorical data is the bar chart. A bar chart gives us a graphical representation of a categorical distribution such that on the x-axis, we have the various categories. So we have female, we have male. And then we have equal weight of bars that their height will be relative, or their height will be equals to the frequency. We can use the frequency. We can use the relative frequency or percent frequency. In this case, I will use the frequencies. So let me say here is 1, 2, 3, 4, and 5. So here, the first bar, which will represent the frequency or total female, is 3. So we have that right here. So this is female. And we will have the male here. Male height will be 5 because this is, we have 5 here. So we start from here and here. One thing you will notice is that a bar chart, as we go on, you will see what we call histogram. A bar chart has 8 bars separated, or there are gaps between the bars. This simply indicate that a categorical frequency are normally non-overlapping. So a person can be a female or a male. So they are distinct, and then there is no overlap between them. So a person or a data point can belong to one of the classes. So now in this case, we have 2 classes, female and male. So you can see the bars, and their height is proportionate to the values, the frequencies value. So you can see, so this is a bar chart. This bar chart can be vertical or horizontal. For what we have here is a vertical bar chart. And then you can as well draw it horizontal. So far so good. This is it about a frequency distribution covering categorical variable. Frequency distribution of a categorical variable. So we now go in to take a specific example here. So if you look on your screen, you will see this sample data collected. On the distribution of solved rings. So the question says here that actually it is stated that the data from a sample of 50 soft drink purchase. So let's say you are selling soft drinks, and then each time your customer buy, you're going to record which type of soft drink was bought. So here this variable or this data has information on different soft drink bought. So as you can see, these are categorical data that each of the soft drink could belong to only one particular type of soft drink. It could be a Coke Classic, it could be a Diet Coke, it could be a Pepsi, it could be Dr. Pepper or Sprite. So one of those. So then how do we really make sense out of this data, as you can see right here? To make sense out of this data, we start by drawing a frequency distribution table in which each of the categories will be represented. So we start by drawing a frequency table. So let's call it soft drinks purchase distribution. Okay. What will we have first? We have class. Sometimes you can call it group. For this, let's just call it a class. We can have sometimes what we call tally. Maybe you will see it in some books. Don't be confused. Tally, we can have frequency. Let's start with this particular 3 columns. So under the class, let's go and take first the first soft drink category we have or class we have, which is Coke Classic, right? With categorical data, you can go this way. Now, we take this, we can go and count all of the Coke Classic soft drink we have. So from this, our table, our first Coke Classic is this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So if we look all around, we have marked all of them. On the tally side, we can put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. And on the frequency side, we can just put a 19. So we can see the Coke Classic frequency is 19. That is, that we are 19 soft drink from this purchase that we are Coke Classic. The next one we can take is from this table here is Sprite. P-R-I-T is Sprite. And then we can go again and count the Sprite. So here we have again 1 Sprite, 2 Sprite, 3 Sprite, 4 Sprite, 5 Sprite, 5 Sprite. Look in between, there is no other Sprite. So actually we have 1, 2, 3, 4, 5. No, 4. The 5 really crosses. can write it as 5 spy. Okay, so we'll go again. Next. We can go again. Again next and count Diet Coke. Diet Coke. Here again we have 1, 2, 3, 4, 5, 6, 7, 7 Diet Coke. So you again put 1, 2, 3, 4, 5, 6, 7, and then you write that as a frequency for the Diet Coke. You go back and look for the next soft drink, which is in this case here is Pepsi. And then you do the same count for Pepsi again. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Here. 13. So we have 13. 13 Pepsi. Right? 13 Pepsi. Sorry, we left one out. Diet Coke, which is this one. So Diet Coke should really be 8. We go back and then look at which of the soft drink is not marked is Dr. Pepper. And then again, we can go and count 1, 2, 3, 4, 5. So we actually have 1, 2, 3, 4, 5. 5 Dr. Pepper. So this gave us the total frequency distribution for this data in here, as there is no more data point remaining without being accounted for. So after we do the frequency, the first thing to do is to know actually the sum of those frequencies. If it matched with your sample size that you expected, then you know you are right. So our n will be equals to add all of this, that is 19 plus 5 plus 8 plus 13 plus 5, which will give us 19 plus 5 plus 8 plus 13 plus 5, which is equal to 50. So 50 as expected or as stated in the question. The question said 50 Sprite or soft drink were sampled. So you can see that make 50. So with this now, we can interpret this data. We can say, oh, majority of the sales, the type of soft drink that was bought or that was sold was Coke Classic because it has the highest frequency. So if you was a business person and you are going to order soft drink for the next time, you will consider ordering more Coke Classic brand or soft drink as compared to the others. Next to that is Pepsi. So you may order another great proportion of Pepsi and so on. What we have there are frequencies, and we cannot really tell their magnitude in relation to the entire sample. So to get more idea or information on like I was saying, when you're going next time to purchase, what will you purchase more? What percent of your purchase should be Coke Classic or so on? You can go on and calculate the percent frequencies of this particular soft drink. So let's say our percent frequencies will be, for the first one will be 19 divided by 50. 19 divided by 50 give us 38%. The next one will be 5 divided by 50. It gave us 1%. 5 divided by 50, 1%. Okay, here will also be 1%. And then the next one will be 8 divided by 50. Give us 16%. 13 divided by 50 will give us 26%. If you sum up everything, it should add up to 100 like we previously said. So let's say 38 plus 2, 1 plus 16 plus 26 plus 1. But that actually gave us something else. So this should actually be 10 and 10, sorry. So now let's go back and say 38 plus 10 plus 16 plus 26 plus 10. Yeah, this gives us 100%. So this is it. This is the frequency distribution table for the soft drink, a categorical variable. Like I said, you can go on if you want to do a graphic illustration or visualization of the data. You can draw a bar chart for which each of the bars or soft drink category will be on this. So we can have the Coke Classic here. We can have the Sprite. We can have the Diet Coke. We can have the Pepsi. We can have the Dr. Pepper. And then now we come and say, okay, we are going to say, start from 0, 5, 10, 15, 20. Since our highest value is 19, we can stop the y-axis as 20. Now we come and say, okay, Dr. Coke is 19, so we come around here, 19 should end here. Take our bar chart from here. So the next one is Sprite, is 5. And our 5 should be somewhere here. The next one is Diet Coke, which is 8, so 5 somewhere around here. And then the next one is Pepsi, which is 13, so 10 somewhere around here. And then we have Dr. Pepper as 5. If you are using a computer, you can add your label to just anyone reading will know exactly that those are the values there. So this is a summary. So here you can call here frequencies, because we actually use the frequency. If you were going to use the percentages, you will say percentage here. And then here you can say soft drink. If you want to label this. And this, your summary. You have two summaries here of this data. And with this summary, you either look at the table or you look at the bar chart. You can see that the soft drink that was purchased most was the Coke Classic, followed by Pepsi, and the list were the two Sprite and Dr. Pepper. So like this can help you make a decision as a business owner or anyone dealing with soft drink. Maybe you are producing soft drink. Let's say you are a Coca-Cola manufacturing company. You will like to produce maybe more of Coke Classic because that is sold more than all the others. Or maybe your production will be 38% Coke Classic, followed by 10% Sprite, and then so on. So thank you so much, and look forward to seeing you in looking at another aspect of frequency distribution when your data is not categorical data, but rather continuous data. Thank you and have a nice day.